Hi people, welcome to episode 11. In this episode we're going to be going down the road of building a tube bender. So I originally planned to build the CNC plasma cutter to cut the steel to be able to make this. That didn't quite go to plan because the plasma cutter I've got won't cut 10mm steel. The description of the plasma cutter said it would, but every time I try cutting any more than about 5mm it pops the fuse. So there may be something wrong with the machine. I'll probably get it looked at a later date, but at the moment the max I can cut is about 3 or 4mm. So what I've done, I've gone down the road of designing a tube bender, drawing it all up in CAD, and then making the assembly and testing it in the CAD program first so that I know it's going to work. So this is the main plate, this is the die that the tube actually goes in, and then you've got this control arm that goes on the die itself to move it, and then the ratchet pushes on the arm to put the force in to bend the tube. This ratchet handle is what operates the ratchet, hence being called a ratchet handle, and then this is the full assembly that I put together out of all those parts I drew up. So you've got your ratchet handle, the ratchet arm, then you've got the control mechanism, control arm that goes on the die. That's the top plate. That's the main pin that goes through the die to allow the die to rotate around it. And then these bolts hold it together, top and bottom, and sort of sandwich everything in. This pin is what goes through the control arm and through the die. There's different positions. As you pull the die around, you can reset to the next position and pull it round from there. So when you grab this ratchet handle, as you pull, the ratchet arm moves the control arm and pulls the die around, pulling the tube through with it. There is a follower that I didn't draw up, but you'll see that later on in the video. I ended up getting this laser cut out of 10mm mild steel. It was actually cheaper to do this than buy a new plasma cutter, as it turned out. So all these parts are what you've just seen from the CAD drawings. I took 2D images of them and sent them off to a laser cutting company. They cut all the parts for me. And then what I've got to do is make these 4 parts into 2 pairs, so they're then 20mm thick. So what I'm doing here is just dropping a really thick chamfer on there, so that when I put them together I can weld into the groove that's created, and that'll give me a really solid weld to hold them together, so they'll be very strong. As usual, got the gloves and I've got goggles on, even though you can't see it. But once I've done that, as you can see, they go together, and then you've got that nice deep channel that you can get a good penetrating weld into. What I need to do first is clamp them down to the table and get them tacked with the TIG welder. So I've got a 2.4mm tungsten, and it's sharpened to a reasonable point because I'm running high amps. I'm running about 160 amps, I think it was. I decided to try it first without filler just to fuse it together, but it wasn't looking good, so I went on, put some filler in there just to build it up a little bit. If you don't know what TIG welding is, it's tungsten inert gas. So this differs from a MIG welder, which is metal inert gas, which feeds metal in. With a TIG welder, the TIG torch creates the heat and the arc, and then you actually put the rod into the weld. Some people prefer MIG, some people prefer TIG. Welding's welding at the end of the day. As long as you've got your amps right, you're fusing the metal properly, there's not really that much difference. TIG does look nicer when it's finished, and you can get those lovely colourful welds, which you may or may not see later. But MIG is a lot easier. You just pull the trigger and away you go. I ended up MIG welding those two together because it's a lot quicker. So these 2 plates are the top and bottom parts of the die, which I'm going to be using to form the tube. But first of all, I need to get them together at the right distance. So what I'm going to do is take some tubes. These are about a 5mm wall thickness and about 30mm diameter. The holes in the top and bottom plates are 25.4mm. So this piece of steel I'm putting in at the back of the lathe is a precision ground rod, which is ground to 10mm. And the reason I'm using this and putting it in that position is because I've got to make 5 of these. So every time I put a new piece of tubing in, set it to that point, set the length, turn the length down, and I know I'm getting the length the same every time on all 5. So the length I'm going to be setting to 70.95, and then the diameter I'll be turning down, as I say, to 25.4 on the top and the bottom of the tube. So I'll just get this marked up for where it needs to be cut down to, take a mark pass, and then I'll come back out and turn down until I get to the right length. And now that that's done, I can start turning the outer diameter. Just measure to make sure I'm on point. .3435 is close enough. I'm happy with that, so I'll pull it out, use the back stop again, and then turn the other end. So another quick measure, and this turns out to be 25.89, so I need to go a little bit more. Another ½ mil should do it. 1 pass is good enough. It doesn't need to be smooth or perfectly finished. It's only going to be welded anyway. And there we go, 25.34. I'll make up another 4 of those and I'll be back. So now they're sandwiched together, I can go on and get them welded. So I'm going to just put a nice weld on these on the inside, just to keep them in place more than anything. I've got it clamped together with a G-clamp. I'm just dropping some good thick tacks on here, and then I'll be welding them on the outside. So I can get away with just fusion welding this because it's a close fit. And I messed up. I forgot to clean the mill scale off. So what I should have done here was stopped, cleaned the tungsten, and then cleaned the metal up and started again. But I decided not to. I thought I'll finish this one and then worry about it afterwards and clean it up after. So you see me start pulsing the TIG here because I've got a foot pedal, so I'm going on and off with the amperage just to try and get the weld a bit better, getting a bit of soot, getting a bit of crud coming up, which is the mill scale boiling into the weld, which isn't good, but it is what it is. So I've got these all cleaned up and this will go much better now. So again, pulsing just to get a nice flow and get the dime stacked look. Not that it really matters, because within a couple of months this is probably going to be as rusty as a horseshoe. But turned it over, cleaned the other side up this time first, and then did the same thing again, got these all welded up. While I'm doing this, don't forget to like and subscribe and ring the bell. And just to let you guys know, I've started a Patreon. I'll put a link in the description to it, and if you want to build the stuff that I've been building, the tube bender, the plasma cutter, that sort of stuff, all the current and future CAD files are going to be on there available for you guys to download and use yourselves. So that's that all done with some pretty welds. Because the material is going to be supporting it anyway, they just hold it in place more than anything else. So now we've got to make this profile inside this area. And the best way I thought to do that was to draw up this shape. So I made a 2D drawing, plugged in the plasma cutter, and got it working. And yes, it cuts, and it cuts pretty well. So I'm going to speed this up to 50 times because it took about 45 minutes to cut 36 of these, and that's because I'm doing a 180-degree bend. I need 36 of them to do 5mm intervals. So at each 5mm point on that 180-degree bend, I'll have one of these ribs which will support the insert tube so that I can bend it around and then weld that in place. It took a lot of messing around, a lot of fiddling with kerf widths and things to get this to run right, but when I got it running right, I was very happy. You can tell the enthusiasm is oozing out of me. So I let that plate cool down, release them all from it, and now I've got to get rid of all the dross. The dross on the back is basically the remnants of the metal as it's being burnt out. As you can see, it comes off pretty easy with some side cutters. If I had bigger metal, I could just chip it off with a small hammer, but because these are so small, I'm using side cutters, it just makes life easier. So I'll carry on and get these done, and I'll be back. And there we go, all done. These did need a little bit of cleanup afterwards with a sander, but it wasn't much. So they slide in, and then I'll be able to tack these in place, and they should be strong enough to support the tube as I'm bending it. So just doing a quick fit check with the tube. This is the tube I'm going to be using to bend around. Get them all welded in. This is about halfway through. So I'll finish that off and then on to making the main center pin. So I'm making this out of bright mild steel, which I think is more chrome content in it, so it's sort of bordering stainless, I think. But it's pretty tough stuff, and it was hard work to cut. Unfortunately, I haven't got a massive amount of tooling available to me, so carbide tooling would have made this a lot quicker indeed, but got to work with what you got. So I was taking about 1/4 mil cut on each pass, and it was going okay. It was just getting really hot, so I was leaving it for about 10 minutes to cool down, going back in, doing another pass, and then cooling it down again. I've had to bring the shaft out to cut the rest of it down to the right size. So what I'm doing here is just truing it up with a dial gauge to make sure that it's straight, so that when I do the next part of the cut, I'm going to be getting it nice and straight in the right place, and hopefully the transition will be pretty close. Just giving it some very light taps. As long as I can get it within 2 or 3 divisions, I'm happy enough. 2 divisions on this dial gauge is about 0.05 of a millimeter, so that's close enough for me. So now that that's done, we can carry on turning. I've had to angle the cutter here to miss the boring bar that's on the other side. I can't move that because it's in a particular position for a particular job, so I'd rather leave it where it is and just angle the cutter. Carry on cutting the rest of the shaft down, and then I can do a test fit. Unfortunately, I went a little bit too deep with the tool on the start of the last cut, and that just put a little tiny line in the part, which is a pain, but it's not the end of the world. The part's not going to snap. So here we have the assembly from CAD to real life.
As these lights Much better, thank you, Aziz.
So now I can fully assemble it back in the shed. You can see I've done all the ribs now, finished all those. So we'll get this in place and get it built up. I made a mistake here, and you'll find out what that mistake was very soon. Let's see if you can guess in the meantime. And this is the follower I made that I was talking about earlier. So as you're drawing the steel through the die, it sits against that follower to stop it just going around into the bolts that are holding the top and bottom plate together. It supports the back of the tube and doesn't allow it to move, so it can actually follow around the die. You can see it much better from this angle. So as you turn the die, the follower stays still and just allows the tube to be drawn through it. Looking okay so far. So we'll get the tube in there and tack it in place on the end. It's going to be fully welded all the way around when it's bent anyway. And here's the mistake. I put the control arm in the wrong way around. I can't get the bolt into the hole in the die. So I've had to pull it out, turn it round. The holes are now on the inside, so I'll be able to get the bolt through. That's another mistake I'm sure to make in the future again. Just cleaning up a little bit of a clearance issue here with the follower, with the welds on the follower particularly. Top and bottom, so I ended up having to pull it back out and sand the bottom of it as well. So here we go with the first bend. We'll see how we go with this. It was reasonably difficult, and it didn't help that my table was semi-portable. Even though it's a heavy steel table, I was still able to move it around quite a bit. Foot supports are always good. It's even better when you use both feet. But the table was still trying to move. And just here, I felt like it got very easy, and that's because this bent. Yes, it's a steering arm off a car. I thought it would have been okay, but I was wrong, and it split the pipe because the follower moved. So I cut the pipe back off, and I decided enough was enough for tonight, because it was starting to get a bit late. So I pulled the follower out and sorted that out. Made the hole bigger so I could fit a 20mm bolt through, as that one was only 16mm. And you can see the mess it made of the tube. It's okay, I can still use the other end, or at least start from the other end when I sort the follower out, because I've got plenty of material left over there. So I carried on, got this all cleaned up, ready to put the next piece of tube in. So, modified follower in, weld this tube back in here, and see if we can bend it. Hopefully this time it'll go better. So while I was trying this one, I was checking the follower to see if it was deflecting at all, and if the tube was following the die. Once I decided I was happy with it, I carried on. Everything was going okay. It was following the die. I was tack welding it as I was going, just get some nice heavy tacks on there. Even if it meant grinding a bit out afterwards and running a bead all the way around, I was happy to do this because it seemed to be helping. So I was doing a couple of degrees tacking, doing a couple of degrees and tacking again. And I was going and going and going, and it seemed to be going really nicely. Until I felt it go very, very soft. I thought it may have been the heat, so I thought I'll stop and check, and this is what I found. So it split the tube again, and it's just buckled the hell out of it. But it doesn't seem to correspond to where the ribs are. It looks like it does, but it doesn't. So I don't know what's gone on here, whether it's the heat that went into the tube has made it shrink on the inside and pull itself in. I'm not 100% sure. I've been thinking about it since, and I think it's because I didn't put the stay bracket on the side of the die. So I need to make up the stay bracket, and in the next episode I'll hopefully have it done, and hopefully it'll be working. So unfortunately, that's it for this one. I couldn't get this finished. I've been swamped with work. I was at a machining exhibition the other day, which I'll have a video on next week. So make sure you subscribe and keep an eye out for that one. I'm hoping to upload it Tuesday or Wednesday next week. So thanks for watching, and I'll see you in the next one.